In this video, we are going to do two things. First of all, we are going to look at how we can create a soundscape by using multi-channel objects and a single sample loaded inside a single buffer. After this, we are going to start exploring panning algorithms. We are going to create custom panning algorithms to utilize all the different channels coming out of mc.groove. In this case, it's going to be linear pan for all channels, custom pan for each individual incoming channel using a multi-channel sine wave as an LFO, using a loop sync pan looking at the position of each sample in the buffer to derive the pan position, and mixing all those together to create a lot of cool soundscapes. Okay, so I'm going to begin with generating a soundscape using a single sound. Right, so for example, let's look at the built-in audio content of Max, and let's say Vibes A1. Pretty good sounds, pretty short, so we can repeat it over and over again at different speeds, different frequencies, create this nice soundscape out of it. Now I'm going to write this down, Vibes A1, Vibes-A1, and I know from experience that these files usually have the file type of AIF, the built-in content of Max MSP. Okay, right, so this file is going to be my starting point. And the first thing I want to do is to create a buffer, right, which is going to store audio samples in the memory of the computer, in the RAM of the computer, which is really useful if we want to play it multiple times, stretch it out, play it backwards, and so on and so on. And I'm going to type in the argument. So first of all, a name for the buffer. Let's just call it Vibes, and then the file name, which would be vibes-a1.aif. I don't need to specify the duration nor the channels because, the file itself is going to contain that. And if there are no errors, it already means that we succeeded, but let's just visualize it for, just for clarity. So I'm going to create the object waveform, which is a buffer viewer and editor, a fantastic object. And then I'm going to give it the attribute of buffer name. So buffer name is Vibes. And as soon as I do this, we're going to see this nice UI that shows you the waveform of the buffer. And this is a very versatile object. You can make selections, you can get information from the buffer, you can automate certain selections within the buffer using this graphical interface. But right now in this video, we are not worried about that. This is just to see what we have in a visual way. Okay, now to play this back, normally I would use, of course, Groove tilde, which would play back this buffer in different speeds, different pitches. But since this is an MC tutorial, I'm going to, of course, use mc.groove. And I'm going to give it the attribute loop1. So, when I play this, it keeps repeating. Since this is about a 1 second long sample, I don't want it to just play and stop. You might have noticed I have not given it an argument for the amount of channels it's going to use, and that is because I'm going to send in the playback information using mc.cycle, which is going to contain the right amount of channels. So let's give it 10 channels. So when this information is sent to mc.groove, it is going to know that there are 10 channels from this incoming MC signal, and it's going to generate 10 instances of groove and played back. Okay, and for the playback, so let's see, what do I want to do? So first I want to mix this down. So I'm going to create mc.mixdown. As an argument, I want to have stereo output in the end, and I'm already going to, whoops, that is the wrong key. There we go, I'm going to turn on auto gain 1 as the attribute. Furthermore, we can, let's see, I can use mc.live.gain to have a nice volume slider in here. And then finally, I can MC unpack this information, this 2-channel MC signal. And then finally, I can create my easy DAC and route all information here. And right now, we're of course going to get 0 sound because mc.groove, well, first of all, mc.groove does not know what to play, right? That should be the very first argument of mc.groove, or groove as well. I have to type in which buffer am I going to read from. So in this case, I want to read from Vibes. And then let's turn down the sound here already. second of all, I have to use this mc.cycle to send information for the playback. And this is how Groove and mc.groove works. So left inlet equals, let's say, playback speed. Right, and this goes from, well, 0 to 1, or actually more or less, but here 0 equals no speeds, 1 would equal normal speeds, and then 2 would equal, for example, 2 times the speed, right? And if I do -1, it's backwards normal speed. So you can really go very creative with how you play back this buffer. So let's try something normal. So how about I just send the information 1 to mc.cycle, which sends an MC signal of 1 to mc.groove. All instances of mc.groove play the same thing, and it's mixed down. So we get something like this. Okay, this is literally the buffer, right? It's not very interesting. Maybe we can play it backwards. Twice the speeds. Backwards, twice the speeds. A lot of cool possibilities, but of course I think we can get a bit more creative with how we do this, right? So instead of just sending in a single number to mc.cycle, I can use, for example, the increment message, something I covered in the previous video, all kinds of different messages you can send to MC objects in order to create a spread of values. You're free to check out that video if you want to learn more about how exactly MC objects work and how these messages function. But in this case, I'm going to create an increment message, right? The first value after that is going to be the amount of the increment. Let's set it to 0.1. And the second value is going to be my starting point. Let's also set it to 0.1. And if I send this to mc.cycle, I'm going to get a multi-channel signal. Look at this 0.1, 0.2, 0.3, 0.4, and so on. So all instances of Groove are going to play at a different rate. And it's going to sound something like this. It's really cool. It's already a soundscapey feeling, and we can mess around with this increment. For example, I can increase the increment. I can make it go backwards. I mean, there are a lot of possibilities here. We can just devote an entire video just to this subject, right? But for now, I just want to have these slow sounds. Right, and notice how the pitch is shifted as well, because by default, if we are slowing something down, it's going to sound much more lower pitched. This is something we can affect by, I believe, one of the attributes of mc.groove, which should be not the time stretching mode, but, well, why don't we look at the help file of mc.groove and figure this out, how to decouple the time shift from the pitch shift. So if I go to the help file, I can look at time stretch, and there we go. When time stretch is on, pitch and playback speed are decoupled. So I just have to turn on time stretch, right? Time stretch 1. Now there we go, they're all the same pitch now, they're just coming in at different speeds. So this is different than having this soundscape of a dense collection of pitches. But I personally like it better when the time stretch is off, but we can make this optional by creating, let's say, the message, time stretch, $1, and we can connect a toggle object to that message box, which would then go to mc.groove, so we can dynamically control how the time stretch functions. Okay, fantastic. So now we have created this kind of sort of a soundscape, but we haven't dealt with panning yet. So let's talk about panning. Now, there are a few different ways of implementing panning algorithms in Macs, but the MC world makes this very easy. And one of the reasons it's really easy is because of this guy right here, mc.mixdown. mc.mixdown, of course, mixes down the incoming audio signals in stereo signals or mono signals or even different amounts of MC audio signals. But what it also does is, well, panning. the second inlet of mc.mixdown here controls the pan. It sets the pan positions. It expects a multi-channel signal, and each signal is expected to go from 0 to 1. So let's play around this. Let's play around with this idea. So first I'm going to send a single audio signal, right? I'm just going to create a regular sig, and I'm going to control the signal that's coming by using a floating point number. Right, so if I turn the audio back on again. Okay, so right now we have 0. It's all the same. If I type 1, it's completely normal again, but if I type in 0.25, suddenly we are just hearing everything from the left channel. The panning is all the way to the left. If I type in 0.75, the panning is all the way to the right. Now this might be a bit different from what you're used to. Usually panning controls are linear, right? 0 would mean the left channel, 1 would mean the right channel, and everything in between would mean everything in between. So let's again check out the help file of mc.mixdown. And if we look at circular panning here, you can see that the default pan mode, so the attribute pan control mode, which is by default 0, is a circle where 0.5 is the front middle and 0 and 1 are in the rear middle. And there's a nice graphic that explains this. So this is a default panning of mc.mixdown. Since we are outputting 2 channels, the attribute is 2. The first channel is to the left, the second channel is to the right, and this panning control determines where we are in the panning. Now this is useful. The circular panning is useful, especially when you're outputting more than 2 channels, when you want to have a 4-channel or 5-channel or an 8-channel surround system. Then you can use the circular panning to target different areas of the incoming sound signal. You can route the incoming MC audio signals to multiple panning destinations. We might get around to that later, but right now I want to focus on pan control mode 1, which is the good old linear panning that we are all used to, the panning that we all know and love. Right, and just like before, this goes from 0 to 1. The first channel would be the left one, the second channel would be the right one. 0 would mean the first channel, 1 would mean the second channel. And once again, if we were outputting channels more than 2, in this case 5 channels, they would all be situated between 0 and 1. Okay, so let's change pan control mode to 1. Right, so I'm going to give the additional attribute of pan control mode 1. So then we should have linear panning. So if I type in 0 here, I'm going to get, there we go, it's all the way to the left, it's all the way to the right. There might be a few clicks in between because I'm very rapidly changing the panning. We can fix this later if we have to, but right now the point is that it works. Okay, now here comes the cool part. Right now I'm doing this with a single audio signal, right? So all of these incoming audio messages, audio signals are being panned to the same location according to this audio signal. So what if I sent a multi-channel signal to the second inlet of mc.mixdown instead? So what if I used, let's say, mc.sig, or let's not use mc.sig, but what if I use mc.list, which would create a multi-channel signal from a list of values. And as an argument to begin with, I created a list of 10 zeros. I said 0, 0, 0, 0, 0, 0, 0, 0, 0, and 0. Now this will send a multi-channel signal of 10 elements. Right now they're all 0. And if I want, I can send mc.list a list that would specify the new values. So I can type in peg 0, 0, 0, 0, 0, and 5 more zeros. Is this right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. And I can also create a nice interface by adding a lot of floating number boxes to this pack, but just for now I'm just going to do the, let's say, the first 4. There we go. Okay, so right now the panning information is coming through an MC signal and they're all 0. So what we should hear is, of course, all the sounds coming from the left speaker. Okay, so let's try changing the list. So right now I'm going to change the first element of this list to 1. So now the MC signal is sending 1, 1, and the rest are zeros. And maybe you can hear it, or maybe you can just see it from here, but we are receiving one of these 10 MC signals from the right speaker, while the rest are coming from the left speaker. And I can customize this in any way I want, right? I can do it like this. And now we have a better mix and more strict, more intricate control of how panning works when it concerns MC objects and MC signals. Really cool. So let's play around with this for a bit. What else can we do when we are concerned with panning? So why don't we use once again an LFO, low frequency oscillator, to control this panning? So let's say I want to create an mc.cycle. Again, this is something I did in the previous video, or introduction to MC objects. And I'm going to derive the frequency of this oscillator by using mc.cycle, which is going to have the attribute chance 10. Right, and then I'm just going to copy this increment setup I have going on in here. And I'm already going to set it to 0.1 and 0.1. And I know that mc.cycle is going to oscillate between -1 and +1. And I want it to oscillate between 0 and 1, my panning values. So I'm going to use mc.scale -1 to 1 and scale this to 0 to 1. And now let's feed this to the panning and let's see how this sounds. Sounds really cool. We can even visualize this a bit further by using the MC scope object, which is going to visualize the audio signal, try to visualize the waveform. I especially like it when I use the automatic one attribute, which is going to make it look very clear like this. So this is a graph, kind of the scope of our panning or multi-channel panning. Each frequency, each MC channel is panning at a different rate, creating this even cooler stereo soundscape effect. And the last thing I want to show concerning this whole panning thing concerns the second outlet of mc.groove. Now this is really cool. This is one of the reasons I love Groove, and it's this second outlet, which is called loop sync output. And more specifically, what loop sync output does is it sends out values, more of a ramp that goes from 0 to 1, right? And let's say, and it's kind of an indication of where we are in the buffer. So if we are reading the buffer from beginning to end, it's going to start counting from 0, it's going to go up all the way to 1, and then when the loop happens, when we start from the beginning, it's going to go back to 0. Now this is going to come out as a multi-channel signal, of course, since we are in the MC realm. So I'm going to create an mc.number to monitor all of these different numerical values coming in from the second outlet of mc.groove. So see what's happening here. This number is slowly rising. This will coincide with the first channel that is coming out of mc.groove. This is the rate of the playback, where we are in the buffer. And this will always go from 0 to 1. So why don't we use this? Why don't we take this value and literally just feed it to the panning control? In this case, we are going to have, I believe, a system where the left channel is going to be the attack of the sound. We are going to begin completely from the left channel, and as the sound evolves over time, each individual sound is going to move to the right channel in its own rate. And this creates kind of a cool effect if we, for example, delete the left channel from the playback. We're only hearing the second part, right? The sustain and release portion of the sample. I can even connect this to the left speaker to get this nice patty soundscape. Really cool effect. Maybe it would be also cool to have it from both ways, right? Like, let's say I want 5 of these channels to start from the left, and I want 5 of these to start from the right, and I want these to cross over as they evolve, as they, as these samples play back. So to achieve this, I would first need to split this 10-channel MC signal into 2, so 2 channels of 5. I would do some, let's say, mathematics or some processes on one, then I would put them together. So I'm going to use mc.separate to split a multi-channel signal. It wants to know how many channels each outlet is going to have, I believe. So I would need to type in 5 and 5. So it's going to have 2 outlets. So if I connect this to the second outlet of mc.groove, it's going to send the first 5 signals from the first outlet, the second 5 signals from the second outlet, and another one in the third outlet. For some reason, I don't know why that is the case. So in the middle here, I want to do something, and then I want to use mc.combine to combine these inputs. I'm going to have 2 inlets, right? It's going to go here. The second one is going to go there, and the result is going to go to the pan right here. Now, if I want to, I can use mathematical processes, and I can try to figure out the algorithm to flip the progression of 0 to 1 to 1 to 0, but I don't want to be concerned with mathematics right now, so I'm again going to use my favorite object, mc.scale. So I'm going to receive values that go from 0 to 1, and I want to scale this to from 1 to 0, effectively flipping it. And now we should have our results. Try to listen for it. The first 5 channels are starting from the left channel and they're going to the right, and the last 5 channels are starting from the right and going to the left. If you have headphones on, this creates a really cool stereo soundscape effect. And that's it really. Once again, I say this in all of my videos, right? You can do all kinds of cool things. You can try out different different LFO types, maybe different waveforms to drive the panning, maybe use more intricate algorithms when you are calculating the position in the buffer versus where we are in the panning. You can try to load in different kinds of samples to this buffer, use other kinds of sounds to see what kind of soundscapes you get, and try to create really cool, really fun, really intricate, awesome soundscapes. Thank you for watching.